Hello, my name is Russell Michael Hall. I'm doing this project for my ET 450 Capstone class. The project that I chose to do was a humidity control system. As you can see, I have an orchid in this container. The preferred humidity for this species is between 50 to 80% humidity. For this project, I chose to have my target humidity set between 60% and 80%. When I originally started this project, I was living in the desert in California. The humidity is very low, and that's what gave me this idea. Orchids are tropical species that are used to high humidity. There are also other hobbies, such as keeping reptiles, that also need high humidity, and other types of plants and animals that come from high humidity environments. This project is meant for the local hobbyist, also for zoos and museums who would like to display species from other environments that don't meet the requirements for the environment that you're displaying the species in. I also wanted to keep this project as a one-piece, all-contained project. To be a single unit. As you can see here, this is for one species. The idea is if you have several species, you could have several of these containers, and you could set each one to its own humidity range. As you can see, I've got the aquarium that houses a tropical species. And for the power, I have one power cord that plugs into a standard outlet, and it also plugs into the back. There's a small water reservoir to house the water for the humidifier to add humidity in an environment that doesn't have a high enough humidity range. This container will hold the humidity. I also have vent holes drilled in various places. That way, when the humidity gets too high and the fan kicks in, lower humidity from the outside environment can enter the container and bring the humidity down if the humidity gets too high. There is an LCD display. This is the DHT11 temperature and humidity sensor. This is where the project starts. Inside this aquarium, this sensor will detect what the temperature and humidity is inside the container. It will send a signal down to the Arduino, which will then be displayed on the display. If the humidity is too low, there is a humidifier installed inside that will raise the humidity. Humidity will appear as fog coming out that hole. When the humidity gets too low, like in this case, 43%, the humidifier kicks on and adds humidity to the container. As you can see, the container is filling up with humidity. And underneath is the reservoir for the humidifier, which is fed through this hose to a larger reservoir. Inside, I have mounted a water level sensor that will alert me via cell phone if the water level gets too low. Also, there's this LED light that will turn from green to red if the water level is too low. There is an alarm that will sound for 5 seconds, then it'll go off. It will repeat this every minute. This will indicate that the water level is too low. I'm not going to make you wait a whole minute, but it will repeat again after a minute. If the humidity inside the container gets too high, this fan will kick on, which will force the humid air out and lower humidity air from the outside into the container, lowering the humidity. Now for a look on the inside. Here is the LCD display. It connects to the breadboard, which then connects to the Arduino Uno. The DH11 humidity and temperature sensor also connects to the breadboard. It then connects to the Arduino. The Arduino runs the program for all the logic and transfers that data to the display. This is the ESP8266. This is used to add Wi-Fi to the Arduino Uno. When the water level sensor detects that the water level is too low, the ESP8266 will connect to the local Wi-Fi router. Then it will make contact with a website called blink.cc, which will send a notification to my cell phone, and it will alert me when the water level is too low for the humidifier. The humidifier, which is this piece right here, has its water supply and is connected to the water reservoir to keep the water supply full. The humidifier plugs into this circuit board right here, which is connected to the Arduino. It is operated by that transistor. The Arduino will send a signal to the transistor, which acts like an electronic switch, and it will turn on the humidifier. The fan is also connected to its own transistor. And there is also a diode to protect the Arduino from reverse spin of the fan when the fan turns off. This is the buzzer. This is the power module. This power module connects to a standard 120 volt outlet and provides power 5 volts to this rail and also this rail. These two rails power the ESP8266, the humidifier, the fan, and the Arduino is plugged in to the USB port on this power module. It's not plugged in at this time because I had to unplug it to open up the case to walk you through all of these wires and components that are contained in this case. As you can see, I used hot glue to keep all the components together. That way you can move the case around and transport it if need be without the worry of your components falling out everywhere. A red, green, blue LED for this project. It plugs into the ESP8266 right there. The water level sensor sends a signal to both the Arduino Uno and also the ESP8266, which is part of the alarm system. So when the water level gets too low, the red portion of this red, green, blue LED will shine red. When the water level is fine, it will shine green. And that is controlled by the ESP8266. Here is where the water level sensor connects to the ESP8266. This is the humidity control system. When keeping plants and animals, especially animals, it is called husbandry skills, and that typically means that you are responsible for the well-being of the plant or animal that you're keeping. For example, instead of having this orchid, if this was a tropical lizard who needed high humidity, it would be unfair and unhumane to keep this lizard in the dry, low humidity desert in California. As an engineer, you have the ethical responsibility to take care of whatever species you are housing. That is the main purpose of this project, is as an engineer to fulfill your ethical responsibility to take care of the requirements and the comfort of the species that you are trying to keep. The humidity control system will allow you to do that in dry climates.